right, this is lesson 6.5, and in this lesson we're going to be talking about the conditions for rectangles, rhombuses, and squares. So the first theorem says if the diagonals of a parallelogram are perpendicular. So in other words, we're just starting with what we know as a parallelogram, and we see that the diagonals are perpendicular. Well, then we can classify that parallelogram as a rhombus. So if you have perpendicular diagonals, then you have a rhombus. The next theorem says, if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So if we know we have opposite sides parallel, so it's a parallelogram, and one of the diagonals is bisecting opposite angles, then you know you have a rhombus. So in other words, all of the sides have to be congruent because that's what we know about a rhombus. Next, if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle, which would mean that all four angles are 90-degree angles. All right, now these are the properties on the right side of parallelograms and rhombuses and rectangles and squares. And this is something that you want to know, okay? You want to know all of these. So the properties of a parallelogram. Two pairs of opposite sides are parallel. Two pairs of opposite sides are congruent. Two pair of opposite sides or opposite angles are congruent. Consecutive interior angles, they have a sum of 180. And diagonals bisect each other. Those are true for all parallelograms. And then if you have a rhombus, all of the properties of a parallelogram are true for a rhombus that are true for a parallelogram. So all of these are true for a rhombus. Plus, you have four congruent sides, and you have diagonals that are perpendicular, and the diagonals bisect the angles. And then if it's a rectangle, it has all the properties of a parallelogram, which are listed above, but then it has four congruent angles, which means they're all 90 degrees. So 360 divided by 4 is 90, and the diagonals are congruent. Now a square also has all the properties of a parallelogram, plus it has all of the properties of a rhombus, so all of this is true about a square, and all of the properties of a rectangle, all of this is true about a square. So let's just run through these questions. This isn't on the note guide, but these are part of the assignment. So it says, name all the special parallelograms that have each property. Diagonals are perpendicular. Well, we see that here, so we would say rhombus. And everything that's true about a rhombus is true about a square. So it would be a rhombus and a square. Next, diagonals are congruent. That would be a rectangle. Property of a rectangle. And the properties of a rectangle are also true for a square. All right, the next one says diagonals are angle bisectors. Let's see. So that happens in a rhombus. And it happens in a square because everything about a rhombus is true with a square. Diagonals bisect each other. Where do we see that? Right here. That's a parallelogram. Now, if it's true for a parallelogram, well, here's the deal. A rhombus is a parallelogram, so it's true for that. A rectangle is a parallelogram, and so is a square. So it's true for all of these, that the diagonals bisect each other. And lastly, diagonals are perpendicular bisectors of each other. Let's see. Diagonals are, where's that at? Right here, rhombus. So they bisect each other and they're perpendicular, so that would be a rhombus and also a square. All right, so that's how you think about problems like that. And you'll see some like that on your test. Next one, can you conclude that the parallelogram is a rhombus, a rectangle, or a square? Well, let's just go back. All we know here is that we have a quadrilateral and one set of angles is getting bisected. So let's take a look here. It tells you in the second theorem that we looked at today, if you have a quadrilateral parallelogram and if one diagonal bisects the opposite angles, then the parallelogram is a rhombus. So this is a rhombus. Now in this problem, we don't have anything about diagonals bisecting angles. They bisect each other and they're all the same length. So the diagonals are congruent, which tells you it's a rectangle. It is, let's see, the diagonals are also perpendicular, so it's a rhombus. Now, if you have a quadrilateral that is a rectangle and a rhombus, if you'll recall, we learned that it also is a square. So a square is the most specific name because it encapsulates all of the properties. All right, next, a parallelogram has angle measures of 20, 160, 20, and 160. Can you conclude that it is a rhombus, a rectangle, or a square? So I like to draw a picture. So 20, and we know that it's a parallelogram, so opposite angles are congruent. 160 and 160. All right, so we don't know anything about angles getting bisected. We don't know anything about diagonals. We don't know anything about opposite side lengths. So let's see. We know it can't be a rectangle because we don't have 90-degree angles. We don't know anything about the sides, or like I said, if diagonals are perpendicular. So we would say not enough information. The next one says, suppose the diagonals of a quadrilateral bisect each other. So that means this and this are equal. And we know that these two are equal. Now, we don't know if they're the same length. Like this could be 5 and 5, and this could be 6 and 6. They're bisecting each other. Can we conclude that we have a rhombus? Well, we don't know if they're perpendicular or not. A rectangle? Well, they could be the same lengths. I mean, they could be 5 and 5 and 5 and 5, but we don't know that. Or a square. So we don't have enough information here either to make any conclusions. All right, here's another one. For what value of x is parallelogram ABCD a rhombus? So with a rhombus, diagonals bisect the angles. So you're going to set those equal to each other to solve that for x. Okay, and then you would solve for x, and I won't do that now. Assuming you know how to do that. This next one says, for what value of y is parallelogram DEFG a rectangle? So with rectangles, the diagonals are congruent, and they're also bisected. So all of these are the same length. So again, you would set those equal to each other. My pen is getting tired today. It's not working the greatest. And then you would solve for y. All right, the next one says, your class needs to find the value of x for which parallelogram DEFG is a rectangle. The classmates' work is shown below. So what did they do? They set these angles equal to each other. What is the error? That's not the way you would do a problem like that. So if you have a rectangle, those angles are not necessarily bisected. If your rectangle happened to be a square, which is a rhombus, then they would be bisected, but you can tell even by looking that those are not going to be congruent. So you have to think about, what do you know is true about the corners or the angles in a rectangle? Well, they add up, they're equal to 90. So these two angles would add up to 90. So you would say 9x minus 6 plus 2x plus 8 equals 90. So we would add those together, and then you would solve that equation for x. So that's how you would do a problem like that. All right, so your assignment is this, page 386, 1 through 4, 8 through 14, 17 through 19, and 36 through 38. Thanks for watching this lesson.